All right, good morning, class. So today I wanted to talk about some concepts that came up on your ingenuity work, and I think this will be very helpful for those of you getting started on your assignment or completing your quiz. So first thing is DNA. We already know are the instructions inside all of your cells that help you make protein, and they tell your cells what to do, what they need to do in order to grow, in order to reproduce. There are specific segments of DNA. Remember, DNA looks like a double helix. Specific segments of DNA are called genes, and genes code for traits. Traits are part of one's physical appearance. For example, the shape of your ear, your eye color, your skin tone, your height. Traits. And a new word that you should have learned about is alleles. Alleles are different versions of traits. So alleles are different versions of genes. For example, let's say that this section that I highlighted here is supposed to tell you the gene for eye color. So the gene would be eye color, but the alleles might be brown or green or blue. All right, another important thing is they talk about dominant and recessive. Dominant means it can do an override. It is the powerful trait. Recessive is sometimes hidden. And we'll talk about it. So everyone gets alleles, or almost all of your cells have alleles from each parent. So you have two alleles. Sometimes they're the same, sometimes they're different. For example, let's think about mice. Let's say the big B means they have big ears, and the little b is the allele for small ears. So if we have a mouse that has big B, this is their genotype, or what genes they have. They have these two alleles, the big B allele and another big B allele. So they're definitely going to have big ears. If a mouse has little b, they have both alleles for small ears, so they're definitely going to have small ears. And if a mouse has big B, little b, then you can be certain that they're going to have big ears as well. Even though they have one of each allele, they have an allele for big ears and an allele for small ears, because the big B is dominant. Big B is dominant, the little b is the recessive. The big B is going to do an override of the small b. So you'll have rat with big ears, or mouse with big ears. So, and the last thing I wanted to talk about, or two more things I wanted to talk about, are the generations that they talk about with Gregor Mendel. The P generation are the parents, and they use the term in the video true breeding. What true breeding means is that an organism, a living thing that has this genotype, is only going to have babies that have the same traits as it. So, for example, from the mouse example earlier, if a mouse has two big B's, all it can give to its offspring is a big B. So it's a true breeding mouse. If a mouse has two little B's, then all it can give to its offspring is the little B allele. So it's a true breeding mouse. When you cross big B and little b, this is something that they didn't talk about in the video that I think was very helpful. Big B, little b, little b, little b. You do a Punnett square. So parent 1 gives a big B. Parent 2 gives a little b. Parent 1 gives a big B. Parent 2 gives a little b. Parent 1 gives a big B. Parent 2 gives a little b. Parent 1 gives a big B. Parent 2 gives a little b. So all of the babies, this is the F1 generation. all have this genotype of big B, little b. So the P generation, I remind you, are the parents and their true breeds. The F1 generation, they all have the big B, little b. And the F2 generation, in order to get to the F2 generation, you have to cross two members of the F1 generation. So you're going to cross big B, little b, and big B, little b. So if we do the Punnett square for that, we'll get one big B, one big B, one big B, one little b, one big B, one little b, one little b, one little b. So here you'll see dominant, they're definitely going to have big ears, right? One. This one's going to have big ears because they have the dominant big ear allele. This one's going to have big ears because they have the dominant big ear allele. So we have a 3. These are dominant. They're big ears to 1 ratio. So when they talk about in the video that 3-to-1 ratio, and they talk about in the assignment 3-to-1 ratio, they're talking about the fact that 3 of them are going to have big ears and 1 of them is going to have small ears. Now I want to give you an example of they give you in your homework. We're going to talk about curly wings and straight wings. So there are fruit flies, and if they're true breeding, then you can assume the big S, little s. When you cross these true breeders, we're going to say this is straight wing, and the small s's are curly wing. When we cross them, this is the P generation. When we cross them to make the F1 generation, we have big S, little s, big S, little s, big S, little s, big S, little s. So everything in the F1 generation is going to be big S, little s. And we're saying that the dominant allele is a straight wing. So all of them are going to have straight wings. They're all going to have straight wings, but they have the gene for straight wings, and they have that hidden allele for curly wings. So when you cross in the F2 generation, you cross one that has a straight wing allele and a curly wing allele, and another one that has a straight wing allele and a curly wing allele. We're going to see the same thing. We have a 3-to-1 ratio. 3 of them are going to have 3 out of the 4 are going to have straight wings. 1 out of the 4 are going to have curly wings. So this means 75% of the babies, it's 75% likely that they're going to have straight wings. 25% likely that they're going to have curly wings. Alright, so that's all I have for you. If you have any questions about this video, make sure to leave a comment or send me an email at elen.mendoza@tuhsd.org. It can be any question. It can be a question about this video. It can be a question about a specific homework assignment or a quiz question. And if I get enough questions, I'll make sure to make a video addressing your question.